Kog Jovanovića? Zorana Jovanovića? Ne. Pa, nismo se nešto čuli. Tako da možda dođe, ali ne znam formalno. A kako se uključuje ovo? A misliš, čuje se već? Dobro.
Neško, ja ću da gledam u vas. Ovo sve podržimo, ništa ne dira.
Dobar dan. Molim vas da zauzmete svoja mesta. Dobar dan. Molim vas da sednete. Treba da počnemo. Please, ladies and gentlemen, take your seats. We will begin shortly, please. Thank you. Good morning, ladies and gentlemen, and welcome to the 33rd TELFOR conference. Before we begin, I will make the usual introductory remarks. We operate bilingually, and translation headsets are provided on demand. Just raise your hand if you need it. Only Serbian translation is provided. In addition, please make sure that your mobile phones are muted, or even better, switched off. Although we are almost all in area of mobile communications, but this is a huge conference. Poštovane dame i gospodo, dragi sadašnji i budući direktori, poštovani predstavnici RATEL-a, poštovani predstavnici IEEE-a regiona 8, inženjeri, profesori, vizionari, lideri novih telekomunikacija, kako to mi obično kažemo, u ime Programskog i organizacionog odbora, velika mi je čast, ali i iskreno zadovoljstvo da vas pozdravim na 33. TELFOR-u. I ono što mi već uveliko znamo, kogod nešto znači u telekomunikacijama, on dođe na TELFOR. I meni je zaista beskrajno drago kad vas i ove godine vidim u ovako velikom broju. U prethodne 33 godine bilo je mnogo izazova u organizaciji TELFOR-a. Preživjeli smo i sankcije, i hiperinflacije, i bombardovanje, i petooktobarske promene, i ubistvo premijera, i koronu, i još mnogo toga da ne nabrajam. Čovjek pomisli da ima li još nešto. Prošle godine nam se desila velika tragedija, ali ono što treba primetiti da je ipak ova godina, čini mi se, bila najteža za organizaciju od svih. Znatno teža i od prethodne. Kao nikad u skorijoj istoriji naš narod je ekstremno polarizovan. Nervoza, depresija, agresivnost prisutna je svuda oko nas, nažalost. Iako to mnogi od nas ne osjećaju, mnogo naših prijatelja iz inostranstva nije moglo da dođe u Beograd, zbog straha, iz opreza, i to u naš divni Beograd koji je uvek širio ruke dobrodošlice prema svima. Mislim da svi čeznemo za nekim spokojnim vremenima. Zaboravit ćemo na trenutak, na probleme, bar na kratko izaći iz paranoje i pričati i diskutovati o toj sitnici koja život znači. A da li je baš to sitnica? Nekad je tako izgledalo. Ali zamislite, ako to uopšte iko može u ovoj sali, da samo na jedan dan nema telekomunikacije. Kakva bi to panika i histerija bila? Pre 30 godina to je potpuno drugačije izgledalo. Ono što je karakteristično, bez obzira na sve, telekomunikacije idu i dalje krupnim koracima unapred. Vrijedno je pažnje da smo mi na ovom mestu, pogledao sam tačno pre 8 godina na TELFOR-u, pričali tadašnjoj ministarki zaduženoj za telekomunikacije, da se što pre pokrene proces dodele 5G licencije. Najzad smo došli do tog trenutka. Naravno, iskusno smo pre toga poterali praktično sve evropske zemlje da prvi uvedu 5G, pa smo onda mi sad na početku tog procesa. Zbog tako dugog čekanja, gledajući sad sa strane akademije, imali smo velikih problema da održimo i obrazovni proces, jer realno nema nekih novih aktivnosti, studenti onda pokazuju manje interesovanje, ali čini nam se da smo to uspeli da održimo na potrebnom visokom nivou i siguran sam da će operatorima to značiti u narednom periodu kada krenemo sa izgradnjom 5G-a. Praktično nova era za srpske telekomunikacije može da počne. I to ne samo za telekomunikacioni sektor. Nekako mi se čini da je naša velika uloga i u tome da kompletnoj privredi, industriji, vlastima objasnimo da je neophodna transformacija kompletne privrede koja će sada biti ne samo moguća, nego to i uslov za naš opstanak. Lepo je pratiti društvene mreže, gledati filmove, zabavne programe po ceo dan, igrati igrice, ali od nečega ipak mora i da se živi. I nekako mi se čini da i ovaj ovde skup treba da bude jezgro koje će svoja znanja, svoje kapacitete prenositi i u druge segmente društva i u druge segmente industrije. I sad da se vratimo samoj organizaciji TELFOR. U organizaciji TELFOR-a, kao što znate, učestvuje jako veliki broj ljudi i kompanija, naravno. Ovo je događaj na kome svi zajedno radimo. I ja bih zaista želeo da ne nabrajam sad pojedinačno, da se zahvalim i svim pojedincima i kompanijama na bezrezervnoj podršci. U onom organizacionom delu, ove godine su se neki istakli velikim nesebičnim radom, da bi ovo izgledalo na ovako visokom nivou, kao što vidite. I oni praktično čine radno predsjedništvo sad na ovoj ceremoniji otvaranja i ja bih želeo da ih redo predstavim. S leva na desno tu je profesor Dejan Drajić, član organizacionog odbora, profesor Mladen Koprivica, predsjednik organizacionog odbora, profesor Nataša Nešković, član programskog i organizacionog odbora i moja malenkost Aleksandar Nešković, predsjednik upravnog odbora. Zaista hvala na aplauzu, nisam očekivao, nije ovo bilo prethodnih godina. Kao što znate, okosnicu podrške ovom našem događaju daju sva tri mobilna operatora. Bez obzira i kako su se zvali, oni su menjali imena, vlasnike, ali su uvek svih ovih godina bili sa nama. I mi smo im svi naravno beskrajno zahvalni na tome. Hvala još jednom. A danas su sa nama gospodin Vladimir Lučić iz Telekoma Srbije, gospodin Goran Vasić iz Jetela i gospodin Nenad Zeljković iz kompanije A1. I šta reći, ne treba puno pričati, Telekom Srbija je naravno bio podržavalac od prvog dana. Doduše, prve godine je tadašnje javno preduzeće PTT organizovalo 50 autobusa da zaposleni dođu iz cele Srbije na TELFOR. Naravno, to više nije moguće, vremena su se promenila, ali bez obzira, učešće Telekoma i podrška je vrlo značajna. Sada će nam se u ime Telekoma obratiti generalni direktor, gospodin Vlada Lučić. Izvolite.
Dobar dan, pre svega zahvalio bih se tebi, Ace, bez tvog entuzijazma ne bi bilo svih ovih godina TELFOR-a, mi to svi znamo i ovo je 33. Ja se trudio da skoro na svakom budem, nisam na ta prva tri, ajde kažem, ali posle gde god sam radio i u kojoj god sam zemlji bio, trudio sam se da budem kao gost ovde, eto, počestvovao si me time što zadnjih nekoliko godina i učestvujem na otvaranju zajedno sa tobom. Ove godine je dosta značajna za telekomunikaciju u Srbiji, desilo se 3 događaja koja su poprilično promenila telekomunikacijnu sliku u Srbiji. Prvo, došlo je do akvizicije United grupe od strane Jetela i MTS-a i faktički sad je osim Telekoma Srbije koji ima značajno tržišno učešće sa preko 60% televizije i interneta u fiksnom, faktički Jetel spajanjem s SBB-om postao takođe operator značajnim tržišnim učešćem na tom segmentu, a istovremeno, kao drugi događaj, A1 je krenuo sa razvojem fiksne telefonije i faktički na neki način drugi i treći mobilni operator su krenuli aktivno da učestvuju na fiksnoj, ulaze u fiksnu telefoniju u segment interneta i televizije. Bitan događaj što se tiče tokom akvizicije bio što se i sama medijska deo promenio, tako da zabavni deo medija kao što su sport više nije tačka odlučivanja korisnika i korisnici ne moraju sad o tome da razmišljaju kada odlučuju za nekog operatera, nego svi operateri imaju sav sadržaj, moram pre svega da kažem zahvaljujući Telekomu Srbije, ali mi smo se odlučili na taj potez kao neko značajno tržišnim učešćem da po fair ceni damo svim igračima i nekako smo sad opet vratili i utakmicu kao korisniku na telekomunikacijonu utakmicu. Znači, ko bude, ajde kažem, imao kvalitetniji servis što se tiče internet, televizije, mobilne, imaće toliko korisnika. Samim tim što su drugi i treći operator ušli u utakmicu mobilni, mislim da će potencijalnim korisnicima da se olakša, jer sad na jedan jednostavan način moći će da imaju i sve usluge od jednog operatera i kako bih rekao, samim tim čini mi se da se ova telekomunikacijona borba za jači kvalitet korisnika jača posle te transformacije. I naravno treći događaj se dešava u decembru kada nam se dele licence za 5G i moram kažem da se veoma radostan i lično, zato što sam ja inače počeo da radim u mobilno i da mi neko rekao pre 20 godina da ću se baviti kablovskom skoro 10 godina, od 2015. u Crnoj Gori pa do 2025. ne bih mu verovao, ali nekako smo iskonsolidovali taj deo tržišta, tako da opet mogu da se vratim da se bavim malo više mobilnom. Iako je realno naš dodela licenciji u principu kasnila za ostalim evropskim zemljama, tehnološki mi nismo u kašnjenju, zato što je naš 4G mreža sva tri operatera izuzetno dobro kvaliteta, što možete vidjeti po merenjima Ratela, ona je čak po mnogim parametrima bila bolja nego neke 5G mreže u Evropi, a to je znak onda i brzog pokrivanja i 5G-a, jer faktički dobar kvalitet 4G mreže zahtjeva veliki broj sajtova, tako da znači da sva tri operatera će onda imati kvalitetnu i 5G mrežu. 5G mreža je bitna zato što ne samo da će, ajde kažem, operateri ponuditi veće brzine, nego što tehnološki omogućava kompanijama da modernizuju svoje poslovanje, one koji u segmentu razvoja da probaju da razviju razne servise bazirane pre svega na veštačkoj inteligenciji i brzom internetu, optičkom ili 5G internetu. Također bih napomenuo što se tiče optičke infrastrukture, da Telekom Srbija također faktički, ajde kažem, kao neko koji je izgradio najveći deo optičke infrastrukture u Srbiji, rentira konkurenciji. Mislim da je to dosta bitno, jer se broj korisnika koji sad koristi aktivno optičku mrežu preći ove godine 600.000 domaćinstava i ubrzano raste, jer drugi i treći operator faktički isključivo i nude internet kroz optiku, tako da u toj, ajde kaže, konkurentnosti vrlo brzo ćemo preći 1 milion domaćinstva koji će koristiti optiku, a to je dosta bitno za razvoj i korišćenje interneta u punom kapacitetu, jer na kraju optika jeste medij budućnosti. Ono što se tiče Telekoma Srbije, baš zato što smo uspeli da konsolidujemo kablovsku, ako kažem, tržište, više ćemo se fokusirati na dodatne izvore prihoda i izdvojio bi samo nekoliko. Eto, moram kažem, ove godine sa ponosom da će nam prihod od zemalja gde nemamo mrežu biti već 12% ukupnog prihoda grupe s tendencijom rasta i mislim da smo tu napravili iskorak koji je retko koji telekomunikacioni operator uradio. Naime, telekomunikacioni operator kad hoće da se širi, klasičan telekomunikacioni operator u neku zemlju, on ili kupi operatera ili izgradi mrežu i to je bila ključna greška telekomunikacionih operatera. Oni su bili uvek fokusirani isključivo na svoje korisnike koji mogu da faktički konektuju na svoju mrežu i na servise ka tim korisnicima, dok su s druge strane digitalne platforme, pre svega američke i par kineskih, shvatili da putem interneta svi korisnici sveta mogu da budu potencijalno njihovi. I sad najveći deo para i profita jeste u digitalnim platformama kao što su Amazon, Facebook, Google, Meta, sa druge strane TikTok ili Alibaba. Sad mi smo uspeli, čini mi se, da napravimo taj iskorak jedne strategije kao što su Amazon i Netflix i u zemljama, pre svega u Austriji, Švajcarskoj i Nemačkoj, pustili smo virtualnog operatera i nudimo naš televizijski sadržaj, otvaramo i u Americi sledeće godine. U Hrvatskoj i Sloveniji prisutni sa sportskim kanalom Arene, znači u zemljama gde nemamo mrežu počinje da nam raste izuzetno prihod i to dosta profitabilan, jer mi faktički isto kao Netflix ili Amazon, mi sa istim sadržajem koji ovde ulažemo, faktički tamo nudimo i uzimamo sad neke pare od nekih korisnika kojih nismo ni imali, niti nikada nismo imali. Znači, otvorili smo potpuno nova tržišta i taj prihod će u 3 godine preći prihod koji imaju mreže u Crnoj Gori i Bosni i Hercegovini. Moram kažem, baš zbog tog iskoraka, kada smo pojavili na berzi prošle godine, smo mi jedina srpska firma koja je na berzi i izdali smo korporativne obveznice. Neviđena je bila potražnja za Telekom Srbija, zato što je strategija Telekoma Srbije strategija koja je vrlo bliska američkim investitorima. I gde firme koje su se okrenute ka digitalnom platformu, ka digitalnom izvorima prihoda, značajnije više vrede. Kao što vidite, recimo i, ne znam, po Tesli u poređenju standardnim nekim proizvođačima automobila ili od digitalne platforme kad poredite s nekim klasičnim kompanijama. Osim toga, drugi segment u koji ulažemo je naravno medijski i sad ova transformacija gde sad svi koriste naše, da kažem, zabavne kanale, omogućuje nam da napravimo veliki profit u tom segmentu, uzimajući obzir da se širimo na čitavu dijasporu. Naš medijski segment od sledeće godine pravit će izuzetno veliki profit i od onog segmenta da je bio kao sredstvo da u stvari privučemo korisnika, sad će biti nezavisna celina izuzetno profitabilna. Sledeći segment je cyber security, jer, kako bih rekao, 5G je jedan segment, ali razvojem interneta sve više, pa i najmanje kompanije će biti, morat će da imaju ozbiljno cyber security rješenje. I ne treba imati iluziju, bilo koja veličina kompanije, da oni mogu same da, ako im nije to core biznis, da stignu u tehnološkom razvoju da naprave dobro cyber security rješenje, jer se s druge strane u cyber napade ulažu velike pare. Sad zemlje ratuju protiv zemalja cyber napadima, tako da će pre ili kasnije svaka kompanija, nevezano na veličinu, biti napadnuta nekim cyber napadom koji u kombinaciji s veštačkom inteligencijom, jer ti koji koriste cyber napad već koriste veštačku inteligenciju, mogu poprilično da unište poslovanje vaše kompanije. Zato smo mi akvizirali kompaniju Pulsek i faktički sad u ovom regionu, ne samo u ovom regionu, nego i zemljama gde ćemo biti prisutni, kao što je Austrija i Nemačka, nudit ćemo naše rješenje cyber security-a, a nekako trudim se sa američkom administracijom da budemo, oni imaju tu neku grupu, zove se NIST, koja faktički drži te standardove cyber security-a, da mi budemo deo tog njihove grupe kako bi delili znanje. Sledeći segment je veštačka inteligencija. Mi ćemo u prvom kvartalu sledeće godine da usvojimo strategiju novu Telekoma baziranu na razvoju veštačke inteligencije, gde ćemo detektovati nekoliko oblasti u Telekomu Srbija, od računovodstva pa do, ajde kažemo, održavanja, call centra, gde će u sledećih 3 do 5 godina biti najjednostavnije uvesti veštačku inteligenciju radi optimizacije poslovanja. S jedne strane, a s druge strane, pošto mi imamo fond za finansiranje startupa i našu kompaniju koja MTSTM koja razvija internet softvere, probat ćemo deo softvera veštačke inteligencije da razvijemo sami kako bi ne bi samo plaćali druga rješenja, već i mi razvili određene segmente primjene veštačke inteligencije na neke delove i poslovanja Telekoma, ali generalno kroz startupe, finansiranje startupa stimulišemo finansiranje svih razvoja veštačke inteligencije u svim segmentima, od zdravstva do telekomunikacija. U intenzivnoj smo komunikaciji, to nam dosta pomaže, kaže američka administracija, sa raznim američkim fondovima kako bi našim startupima omogućili skok sa tog početnog u srednji nivo razvoja, kako bi nam startupi više vredili. I na kraju, ne bi oduzeo mnogo vremena, pošto je ipak na TELFOR-u se dosta i mladih ljudi, inženjera pojavljuje, poslao bih jednu isto poruku. Ono što smo bitno uradili u Telekomu Srbija u zadnjih 5 godina, značajnije smo standard radnika povećali i uveli smo da stručnjaci mogu da primaju plate i van kolektivnog ugovora, znači po benchmarku, tako da s obzirom da smo krenuli na ove projekte veštačke inteligencije, cyber security-a, mislim da Telekom Srbija možda bude poželjno mesto za početak vašeg rada, a ovdje će biti i tehnički direktor prodaje će biti ovdje i direktorka Natali koja je direktorka strategije razvoja, slobodno im pričite, mi primamo nove ljude, tako da eto iskoristite šansu, mislim da Telekom Srbija, trudimo se da od Telekomu napravimo opet neko poželjno mesto za početak rada kakav je bio ranije kada smo i mi kretali da radimo kao inženjeri. Još jednom bih vam svima zahvalio, još jednom Vaco tebi mnogo i svim tvojim saradnicima, tebi stvarno od srca čestitam i vidimo se za godinu dana.
Hvala Vlado puno. Jetel i TELFOR su manje više godišnjaci, pri čemu TELFOR je za nijansu stariji, ali bez obzira na to, Jetel ili prvi naziv Mobtel je bio praktično od prvog dana, čak i prije prvog dana zajedno sa TELFORom. Danas nam je posebna čast da je sa nama gospodin Goran Vasić, izvršni direktor korporativnih poslova u kompaniji Jetel, i on će nam se obratiti. Izvolite.
Hvala puno. Zaista mi je veliko zadovoljstvo sam i ove godine sa vama. Aco, 3 TELFOR-a više imaš. Jetel je kompanija koja je u prethodnoj godini, odnosno ovoj sad postojećoj godini, prošao i prolazi još uvek kroz velike transformacije. Kao što je Vlada već rekao, u prethodnoj godini akvizirali smo SBB, za nas veoma značajan, verovatno istorijski najznačajniji događaj u našoj istoriji i trenutno smo u procesu integracije ove dve kompanije. Prvi deo integracije po našem planu bi trebalo da se završiti negde početkom naredne godine, gde ćemo i praktično pod jednim krovom imati i formalno, i pravno, i organizaciono obe kompanije. Tehnološka integracija će potrajati malo duže, svi ste ovde inženjeri, znate šta znači objediniti sve BSS, IT, Core, OSS sisteme, tako da će nam to trebati malo više vremena i naravno planirano je da već sredinom sledeće godine sve naše usluge stavimo pod jedan brend. Jetel kao kompanija je svoj razvoj postavio na 3 glavna stuba. Naravno, prvi, onaj koji nam predstoji, to je razvoj 5G tehnologije. Evo, očekujemo ove nedelje već da se završe svi formalno pravni procesi, da platimo, da bi već sledeće nedelje mogli da dobijemo licencu. Naša mreža je spremna, mi smo spremni za puštanje 5G u rad. Naši korisnici će svi imati prilike da testiraju naše mreže, nadamo se da će biti svi zadovoljni. Pored razvoja 5G tehnologije, što će biti naravno jedan i od najvećih investicija u narednom periodu, pošto moramo da zadovoljimo sve zacrtane RATEL-om uslove što se tiče pokrivanja. Druga velika stvar jeste, naravno, koji kod svih, razvoj AI-a. Mi smo se prilagodili u prethodnih par godina, našu organizaciju prilagodili ubrzanom razvoju AI aplikacija i raznih AI rešenja. Kako rešenja koja pomažu nama u optimizovanju internih procesa i poslovanja, preko rešenja koja pomažu olakšanu optimizaciju naših tehničkih resursa, naših mreža, tako do AI rešenja koja su usmerena ka našim korisnicima i za cilj imaju da omoguće olakšanu upotrebu svih naših servisa. I naravno, kao i tokom prethodnih godina, digitalizacija. Počeli smo od jedne male aplikacije koja je pre nekih 10-12 godina omogućavala plaćanje samo računa, do toga da mi tu našu aplikaciju pretvaramo u jednu sveobuhvatnu tehnološku platformu koja treba da obuhvati celokupnu interakciju sa našim korisnicima i omogući im olakšano korišćenje svih naših servisa. Eto, toliko za sad od mene. Još jedanput da se zahvalim organizacionom odboru i nadam se da se vidimo i sledeće godine. Hvala vam puno.
A1 Srbija, interesantno, oni su bili na TELFOR-u i pre nego što su nastali. Dakle, njihovo prvo rukovodstvo je praktično godinu dana pre početka rada došlo na TELFOR i prisustvovalo i tu pravilo dogovore. Tako da su oni saradnici TELFOR-a više nego što postoje, što je takođe jako značajno. Danas je sa nama kolega Nenad Zeljković, koji će nam se obratiti u ime kompanije A1.
Poštovane dame i gospodo, uvaženi profesori, organizatori, drage kolege, veliko mi je zadovoljstvo da mogu da vas pozdravim ispred kompanije A1. Kao prijatelj TELFOR-a od samog početka svoje karijere pratim rad ovog skupa i sećam se kada smo na ovom mestu pričali o samim početcima GSM tehnologije, kada smo pratili sve razvoje mobilnih sistema, evo danas, svega nekoliko dana deli otpuštanja komercijalnog 5G tehnologije. Živimo u doba brzog digitalnog razvoja koji nameće visoke standarde telekomunikacionim mrežama. Kako u smislu povezivanja svih uređaja i mašina, tako i u smislu samog kvaliteta servisa. Svedoci smo takođe brzog razvoja veštačke inteligencije koja dodatno postavlja zahteve ispred telekomunikacionih mreža nove generacije. Očekuje se dalja automatizacija i još veća pouzdanost. Na kraju ne samo da zaboravimo naravno i energetsku efikasnost i pametno upravljanje samim mrežama, mrežnim resursima, jer to je praktično veoma važna komponenta bez koje nije moguće zamisliti dalji rast svakog od operatera. Godišnji rast saobraćaja u našoj samo mobilnoj mreži od novembra prošle godine pa praktično do danas je bio 40%. Tako da za nas 5G i novi spektar koji dolazimo predstavlja infrastrukturni preduslov kako bi mogli dalje da nastavimo sa razvojem i sa digitalizacijom i sa daljim razvojem ICT servisa. A1 Srbija je dokazala kroz već 5 godina za redom dobijenim OKLA sertifikatima da je brza i pouzdana mreža naš imperativ i siguran sam da ćemo i kroz razvoj 5G mreže nastaviti tim pravcem. Sa druge strane, svesni smo da dugoročno jedino kroz razvoj optičke infrastrukture i kroz konvergentne ponude na tržištu možemo da podržimo intenzivan rast saobraćaja i potrebe korisnika. Zbog toga je kompanija A1 ove godine krenula sa pružanjem fiksnih optičkih servisa, a naše strateško opredeljenje sigurno jeste da nastavimo snažan rast optičke infrastrukture kako u transportnoj, tako i u pristupnoj mreži. Na kraju, želeo bih da naglasim da mi je drago što se tradicija TELFOR-a nastavlja, jer je ovo jedinstvena prilika da povezujemo našu industriju i akademsku zajednicu. Mesto gde razmenjujemo iskustva i ideje i time utičemo na dalji pravac razvoja telekomunikacije u Srbiji. Hvala na pažnji i uspešan rad.
Hvala puno. Hvala puno direktorima na, ajde da kažem, na tome što su podelili svoje vizije i planove sa nama. Ono što je moj utisak, nekako imam osjećaj kao da su se dogovorili, jer su pokrili sve aspekte, a svako je ponešto drugo rekao, tako da mislim da ništa nije ostalo izvan toga. Puno vam hvala. Sada je vreme za nagrade. Prva nagrada je nagrada Đorđe Paunović za najbolji rad. U znak sećanja i poštovanja na delo profesora Đorđa Paunovića, prvog i dugogodišnjeg predsjednika Upravnog odbora TELFOR-a, Upravni i programski odbor TELFOR-a ustanovili su nagradu Đorđe Paunović za najbolji rad na prethodnom TELFOR-u. Nagradu Đorđe Paunović dodeljuje programski odbor na osnovu obrazloženih predloga. Nagradu može dobiti samo rad koji je prihvaćen i referisan na TELFOR-u, a nagradu za najbolji rad na TELFOR-u 2024. godine dodeljena je sledećim autorima: Jelena Dinkić, Marija Nikolić Stevanović i Antonije Đorđević za rad Square Patch Antena with Ferrit Wall. Ja bih zamolio Jelenu Dinkić da primi nagradu. Prestižnu nagradu dodeljuje profesorka Nataša Nešković, a nagrađenim autorima pripada i lepa novčana nagrada u iznosu od 120.000 dinara. Ovo namjerno napominjem da bi inspirisao i druge istraživače da se potrudi da imamo što kvalitetnije radove. Čestitamo, Jelena. Kao što smo prošle godine na TELFOR-u najavili, od ove godine uvodimo Rnicovu nagradu za najbolji rad mladog autora. Tradicionalnu nagradu najbolji rad mladog autora, koji je prezentovan na TELFOR-u, dodeljuje Fondacija Registar nacionalnog internet domena Srbije. Nagradu dodeljuje posebno žiri sastavljen od predstavnika Rnica i predstavnika programskog odbora TELFOR-a. Kao eventualni kandidati za nagradu mogu biti predloženi autori mlađi od 30 godina, pod uslovom da su prvi autori prihvaćenih radova i da su lično referisali rad na TELFOR. Ove godine žiri je nagradu dodelio kolegi Nebojši Kolariću za rad The Impact of Inverse Matrix Computation on the Results of the Kaplan Algorithm. Koautori rada su Miloš Bijelić i Nataša Ćiravić. Pozivam kolegu Kolarića, a prestižnu Rnicovu nagradu za najbolji rad mladog autora dodelit će direktor Rnica Dejan Đukić. I ova nagrada podrazumeva lepu novčanu nagradu, tako da mladi potrudite se. Hvala puno. And now we have invited presentations. In the last few years, artificial intelligence and its application have been attracted the most attention in all technical fields. Rightly or wrongly, time will tell. And in that direction, the application of artificial intelligence is the subject of two exceptional presentations that will be given today by two truly top experts. The first is our keynote speaker, Dr. Ignacio Mas, coming from Ericsson, research fellow in autonomous programmable networks, and his today's presentation is entitled The Sentient Network Telco Architecture Evolution in the Age of AGI. Dr. Mas, the floor is yours.
Thank you so much for having me here. First and foremost, please excuse me for not being able to switch to Serbian. I have not had the time to actually improve so much so that I will be able to give the presentation perhaps next time. I was planning today to give you a presentation that tries to show a little bit more of the vision of where we are doing. I mean, after spending almost 15 years, being the senior expert in Ericsson about the management and orchestration portfolio, I moved back to Ericsson Research, where I started my career. And I started really thinking about the vision of where 6G and beyond could be telling us. And I know that you're right now, starting with the 5G revolution, so there's going to be plenty of things that we could be talking about what 5G will bring to the table. But hopefully I'm giving you as well, the type of ideas that we are looking when thinking about what else apart from 5G we could be doing in the future. So, a bit of history first to start with. We started, with the generations in telecommunications early by starting with, trying to create a mass market to connecting everybody, to really being able to provide voice and SMS services, where you are having a proper balance, between the usage and then the type of services that you were creating and the monetization, the revenues that you were creating. Then, of course, between 1G and 2G, we started moving into actually providing internet to everybody. And the internet revolution through our mobiles provided with a huge amount of benefits to the usual customers that we were creating. All of a sudden, the business models started to change again, and we started to talk about bit buckets. We're starting to talk about subscriptions that are based on, for example, gigabytes per month, that started to tip a little bit the balance between what is, the cost that you have in order to improve your network versus the revenues that you're going to be getting. But anyway, this really created, a mass market that actually made internet and internet reach almost as a utility. The same way you really realize that you have water or you have electricity, everybody assumes today that you're going to be having internet. But of course, this created, requirements as well on being able to find new ways of monetizing, new ways of really understanding how we're going to be keeping on innovating around the network. The next wave came with a lot of innovation around how we're going to be providing. And it's basically what you're facing right now when you're starting with 5G in Serbia. It's really, starting to provide carrier aggregation of low band and mid band, starting to create, MIMO type of antennas, and being able to provide network slicing as a way to, for example, start differentiating the characteristics that you have into your networks. It does as well start enabling in how to provide services that you could be consuming from verticals, creating network APIs that can be consumed, that can be used as the building blocks to advanced services, services that you could be connecting in the future with more advanced applications that we have not thought about. All of a sudden, 5G enabled a plethora of new use cases. Fixed mobile convergence, it was one of the very early ones. But of course, the arrival of the 3GPP type of networks into industry verticals was a huge boost to the type of use cases and the type of characteristics that we needed to provide from the network. You would see that we are able to expand and differentiate, that we are able to provide new type of services, that we are able to provide new type of characteristics from our networks by scaling new use cases. We have been talking about artificial reality for almost 10, 15 years, and it seems that it's almost there, but it does not really happen. What you are enabling right now with 5G and the way that we are moving into the 6G standardization that it's starting right now, it's precisely moving into creating the networks that we need precisely to do those type of things, to expand to new sectors, to really go into mission critical, to create new business models. Because this is key. One of the key problems that we have had in the industry in the latest years is that, of course, revenues have been flat because of the business models that we created ourselves as a way to provide a mass market, to really introduce internet, to really introduce mobile broadband in all corners of society. But now we are moving into really new capabilities beyond connectivity. So very much this type of use cases and this type of vision is what has brought us here to the age of 5G and to the type of research that we are doing in 6G as the way of really new things that are happening. So I really think a little bit into the future. Allow me to be a little bit more visionary over here. Because, when I moved back to Ericsson Research 2 years ago, I thought it because I did it because I thought that really thinking about where we could take telecommunication networks could be an extremely cool thing to do. And it has been extremely rewarding to try to connect the different activities that happen in research into a homogeneous vision, something that actually tries to enable the network to take the next step. And that next step could be what I call the sentient network. Now, you would say, what is the sentient network? That image, by the way, talking about AI, comes from Google Gemini. I just asked Google Gemini to create an image of what could be, a sentient network. And this is the type of things that a large language model today is able to do. I think that it actually was a really, really cool image to show the type of capabilities that we need. But if we take a step backwards, what is a sentient network? I went into the Merriam-Webster dictionary and I asked, what is sentient in reality? Well, a sentient being, a sentient entity is capable of sensing or feeling. It's able to really be conscious or responsive to the sensations that it sees around it. Seeing, hearing, feeling, tasting, smelling, everything that happens and that provides the context of where you are as an entity. So how do we translate this into a network? Well, basically, what are the key capabilities then that the sentient network? If we move to a network that it's now able to sense in the wider sense of the world, what are the key capabilities that sentient network would need? First thing is that it needs to have self-awareness and self-representation. Most of you probably have heard about digital twins. Most of you have heard about the next evolution of digital twins where people are starting to talk about world models. I mean, you need to be able to actually create a continuous representation of the state of your network, of the different parts of the different functional and implementation domains. You need to be able to create what-if type of functionality so that you are able to, in a digital way, emulate what would be the desired change into a network that then you are applying. And you need to be able to abstract that emulation of the network that you are creating by providing a simplification of how we converge, how we configure, how we actually demand changes into the network. And the industry has moved into what we call, for example, intents as a way to try to use something closer to natural language models, the way we speak, in order to tell the network how it should be behaving. But the most important thing about this digital representation is that it needs to coordinate all the data that is coming. So how does it does that? Well, by providing real-time, and I go back to what real-time what really means, perception and contextual interpretation. If you really have a sentient network, it really needs to integrate a massive amount of data. Traditionally, telecommunication networks uses the FCAPS models, where you are, just aggregating faults, alarms, security information, performance data, and usually it's in a coarse granularity. It's in the order of 10 minutes, 15 minutes, where you're just collecting that information and correlating it to get a feeling of what the network is doing, how the network is performing, if there are some problems on the network. With the movement that the IT industry has provoked into the telco industry by moving into cloud-native type of paradigms, we are moving into a much more real-time feeling of the network itself. We are right now moving the implementation architecture into being able to stream data. And I'm not talking anymore about just performance data or fault data. It's all type of data that you're going to be seeing into your network that needs to be correlated, needs to be, fused into one multi-source data model that then allows you to feed precisely the digital twin that I was talking on the right. So you need to really create some contextual reasoning. You need to be able to understand the context of what the data is telling you. For example, one of the key things that are happening is that the traditional way of doing the packet inspection, into which we are just looking at the 5 IP tuple, you are looking at the characteristics of a network flow, it's moving further into trying to provide sentiment of those particular flows. So now we are moving into deep packet inspection engines that try to understand what is the sentiment of the communication that is happening. That communication could be verbal, could be visual, could be audiovisual, but it's really about understanding whether there is some kind of a mood, whether there is some kind of a feeling behind the communication that you are starting to create. What is the next aspect that you need to be doing? Well, now you have a plethora of information at your hands. You have, the real-time streaming that is coming. You have all the data that is coming from the functional architecture, the different domains of the 3GPP telco architecture, the core, the transport, the radio, the OSS/BSS that we were talking before. But you have as well all the different stream of information that is coming from the implementation architecture, how the different microservices are performing, where are they instantiated, whether you need to get, new instances of containers that are happening into your network because, certain points are becoming congested, whether you need to reroute your transport network, all these kind of things. And all this needs to be doing in autonomous decision-making and adaptability. You need to enable right now that network that it's able to provide orchestrated or choreographed type of decisions that are multimodal in nature. You need to be able to understand how the particular decision of instantiating, for example, a new packet core node, a new UPF, a user plane function, would affect what's happening into the network loads that come from the radio base station, or how would they affect, for example, the way the transport domain is actually transporting the IP bits from one point to the other. All these type of decisions need to be actually be proactive and need to be based into these digital twins that you're creating, need to be based into the type of information that you're collecting and that you are providing with a state view of the world in the sense of the telecommunications network. Finally, the last key capability of the sentient network is really the fact that it's a closed loop. It's always improving itself. It's learning from its own actions, learning from the actions of the users of the telecommunication network. It's really sentient into the sense of feeding machine learning algorithms that consume all the information that you have into the self-awareness models that you have, the digital twins, and that really optimize the network for the best possible performance. How does that optimization actually happen? Precisely, that's the point where a 5G-enabled network, especially when you move into standalone, allows you to start creating differentiation between the use cases, allows you to start creating network slices that could be performance optimized for particular use cases, that could be tailor-made for particular vertical enterprises, for example, a security company, for example, what would be a logistics company, or the different type of industry verticals that you could be serving. So, if we really think about these key capabilities of what I would call a sentient network, how do we actually map them into the technology that has taken us here? Well, some years ago, I used to say that the IT industry was actually colliding with the telco industry and that there was going to be some kind of a mess up of technologies that was happening. I don't really think that it's a collision anymore. I think that it's a merge of technologies. And there are three pillars that have taken us into the position where we are today that allows me to start talking about this vision of a sentient network. The first one is AI. We have talked a lot today already in AI. I mean, we started with traditional machine learning algorithms. And by the way, machine learning algorithms, those are 20 years old. So, I mean, it's not something that we have done today. The only question is that all of a sudden, the evolution of Moore's law and the evolution of processing allows us to be creating practical uses of machine learning algorithms that feed the artificial intelligence engines that are able today to almost act on quasi-real time. And by quasi-real time, I'm talking about something from minutes user time of granularity of a user of the network, but also microseconds to milliseconds if you are really thinking about the type of machine learning algorithms that you are putting into the radio base stations. Next step is really moving into large language models, generative AI. Everybody's talking about it. And it's not only that you're going to be having ChatGPT or Google Gemini allowing you to talk to your network. Yes, that's happening. We are doing it. We are doing it in my company, for example. We are using LLMs, tailor-made LLMs for telco as a way to simplify the way we request and we manage the network. But also, LLMs are generically extremely well suited to try to put order into non-structured type of data. And there's a lot of non-structured type of data that you could be consuming from the telco networks. So there is still quite a lot of things that we are doing with LLMs that will actually allow us to move into a new generation of what we call agentic AI. Agentic AI is basically nothing new. It's basically the fact that you are taking right now agents, and by the way, agents in telecommunications is something that has existed forever. At the HCP server, you have plenty of agents that are actually, requesting IP addresses for your devices, and those are agents themselves. What we call an agentic AI or an AI agent, it's really the fact that you're putting an AI algorithm of whichever sort it is into a self-contained piece of software, and that self-contained piece of software, it's able to collect information, it's able to decide on the next steps of what it's doing, and it's able to act on the network. For example, changing the amount of energy that the radio base station is able to consume based on the amount of users that it has, based on the traffic that it's seeing, on these kind of things. Now, when we move into AI agents and AI robots, the very first thing that happens is that you need to start thinking about how these AI agents are going to be coordinating. And these AI agents are not going to be a complete revolution of the network architecture. They're going to be an evolution. They're going to be complementing the traditional functions that we see in 3EPP. The second aspect, the second independent technology that actually created huge waves into the telecom space, it's of course cloud. Cloud computing came, as the promise of reducing your costs. Then everybody realized that, well, perhaps it's not that much because it has a lot of system integration that actually increases costs. I was actually talking to an American operator that had a goal to virtualize first, virtualized and then cloudify in the sense of containers, 90% of their networks by 2025. They are almost there today. They are in 75% of the network, but their goal was reducing from a cost per gigabyte that they were having around $15 to $17 per gigabyte, something like that of transmission, in order to $3. As of today, they have exploded into 70 because of the amount of integration that it's needed in order to actually make it work in that sense. So there's a huge amount of automation. There's a huge amount of maturity that we need to still, create into how we deal with cloud-native type of execution environments. But of course, there's another aspect that is coming extremely, extremely strong nowadays in the last 2, 3 years, 4 years into the telecom space. And it's the fact that, well, we are not completely sure that we can trust, clouds, public clouds that exist at the other side of the Atlantic or at the other side of the Pacific. So there are more and more talks about creating sovereign clouds. So all of a sudden, that cost benefit that operators were seeing by developing their own clouds that was not there because of the system integration, it's actually shifting and it's having another meaning. And that meaning is creating a sovereign cloud, creating a cloud that you control, creating a cloud that you manage yourself as a way to offer security to your own customers. So this is very much happening as well. But of course, the next step of that sovereign cloud is really creating the old dream of distributed computing, distributed edge computing. We have been talking about HCMEC for many years. It was not that successful. We have been talking about creating container environments into the radio base station so that you are able to run workloads over there. We didn't find really the definitive use cases that was really justifying putting the complexity of execution environments in the radio base stations. But nowadays, as AI moves into the big scene, you are going to be having AI workloads that need to act quite close to the actual traffic sources. You're going to be having AI workloads that perhaps need to run into the base stations, that will be definitely running into the core, will be definitely running as well into the transport domain, and will be taken care of really, how you are creating your distributed execution environment. So yes, we are moving into the edge of distributed execution and distributed computing. Finally, mobile. We have talked very much about the generations that were coming over here, but it's very much related to the fact that when moving to 5G and further away into 6G, we are finally making reality the old dream. And by old dream, I mean, well, when I made my PhD 25, 27 years ago, I actually made my PhD in quality of service. We've been talking quality of service on the internet for 40, 45, 50 years, and it has been a back and forth trip. Well, now with the fact that many industry verticals are coming into the picture and they are putting new types of requirements into the network, finally we are seeing quality of service, finally we are seeing differentiated connectivity happening into the network. And that requires 5G standalone, that requires really moving into creating network slices, that requires really enabling the capabilities to differentiate the quality of your network. So, we are coming here from a set of trends that have actually shaped our industry. And I would like to just give you some of ideas of what those trends are. The very first trend is really that the telco architecture is adapting. I have really talked about this before. I mean, you're going to be having right now a distributed execution that becomes AI native. We see, many efforts from NVIDIA, from other actors, into saying that now you need to be adapting your network so that you're able to create, specific hardware for AI workloads. You perhaps don't need to have, hardware accelerated in the sense of a sidecar like NVIDIA would be doing, but there could very well be, applications that require those type of things. But for the type of use cases that we're thinking right now, you need to really focus much more into what would be the execution environment itself and how you're going to be providing the right security and the right orchestration for those kind of things. Then, of course, you need to have an AI native type of operating system and applications on top. And yes, this is going to be happening in a coordinated manner, both on device. You all that have a sufficiently modern mobile telephone today in your hands have probably Gemini, or at least a small language model of Gemini inside your telephones. This is happening both into the models that you are creating into your devices themselves. And this is just the beginning, because I have the pleasure of actually touching and tasting, the Ray-Ban Meta glasses. And it's actually really cool. I don't have a model, but I'm going to be getting one. And I have seen our CTO, giving a presentation like this with some glasses over here, where, there was a prompt directly, being displayed in his glasses that was actually telling him not only the points that he was making during the talk, but he was even getting real-time translations of what other people were saying in other languages. Of course, the movement of this device AI to private edge AI and to the public cloud AI is the most important effort that we need to do when thinking about orchestration. How will you decide where the AI workloads actually need to be executing and need to be, secured and need to be accessing the data that you are getting from your network? The second trend, I talked about the glasses. Yes, there are many new consumer devices emerging. What is the difference from the last 10 years that we have been talking about AR? Well, all of a sudden, price points are going down. So they are going to be actually accessible for the mass market. Yes, it's happening. Meta Ray-Ban is there. It has around 4 hours of internal battery. It doesn't have a display in that sense, but it does a camera, and it's using, processors that are consumer prices. You have as well, for example, camera booths, and you have, for example, all type of glasses that are happening from the different devices. So yes, this is coming. What does that have as an implication for the network? Well, these devices are going to be generating traffic. How much traffic? That's the key question that we have been trying to answer, in the last 2 years as well in our mobility reports. Will they generate so much traffic that, the current trend of flattish rate of traffic will actually turn and start increasing again? Possibly. Probably. It depends on the evolution and the uptake of these type of devices. So the key question is that the traffic characteristics are changing. It's not that much that you're going to be having a huge increase in download traffic. Yes, it will happen. We are all consuming much more TikTok. We are all consuming much more YouTube. We are all consuming much more Netflix. But still, this type of AR devices probably will not be increasing the amount of consumption that you're going to be having through the month. It will still be in the same type of volumes. However, what happens is that we're starting to generate much more traffic. So the uplink, it's becoming congested. Now you're going to be having plenty of devices that are generating traffic that goes to the big LLMs that are happening to the private clouds, that goes to the public clouds themselves to be analyzed and to be given information back. So you're going to be having much more personalized content that actually, based on Gen AI, enables at hyperscale creation of really things that are absolutely tailored for your consumption. You're going to be having immersive interactions. I have been, in a cooperation with Stanford, where the students are having, AR glasses into which they're able to interact with the physical objects in a room. So they're able to actually touch with the glasses and move their hands and create like furniture that starts, appearing in real time into the rooms themselves, and that allows them to even start, testing physical characteristics like how much a ball bounces on the wall and these kind of things. And then, of course, there's a lot of talk in the industry about semantic compression. What is semantic compression? It's basically a compression type using Gen AI. In reality, it's as simple as saying, instead of actually compressing the bits that I'm seeing through my eyes and sending, a compressed image with different type of algorithms, what I'm going to be having is a Gen AI that understands what I'm looking at. It understands that I'm talking, to an excellent group of people, around 500, here in this room, that I'm giving a talk that is, this type of lighting, and then it actually translates that into a textual description of that visual information that I wanted to convey, and it sends that textual description. What happens is that there's another LLM at the other side that takes that textual description and translates it into an image. That's really what semantic compression is about. Now, questions about semantic compression. Well, first and foremost, you need to consider about copyrights. You need to consider whether, for example, Metallica would like to hear, a version of Enter Sandman generated by a LLM instead of the original audio. But yes, it does have quite a lot of advantages into what we are doing. I already talked about this. Thinking about the traffic volumes that are increasing. Yes, we do see that AI coming into the network, it's starting to create traffic. How much? We still don't know, because it heavily depends on how chatty your AI agents are going to be. For the type of information that we have today, where we are just sending textual prompts back and forth, perhaps there is not so much increase into the traffic volumes. But the moment we move into these devices that have visual capabilities, then we're going to be creating a lot of upload traffic that is going in the uplink. We're going to be creating a lot of traffic that will perhaps require either or both a rethink of the business models that we are creating, perhaps creating separated slices for the network for this type of applications, but also they will require us to think about the architecture that we are creating. Perhaps, the asymmetry of the traffic that we have designed the 3GPP networks for is not there anymore. Whenever you are getting, uplinks that start to be congested in more or less the same volumes as you would be having the downlink. So the future is still quite interesting to follow, but we try to create models that actually predict a little bit of the traffic that we are seeing into the different markets. Okay, so how do we gather together all these trends into what would be, the network that we are creating? First and foremost, the network of the future is going to be horizontal in nature. You're going to be having a set of 3GPP, domains, the traditional ones. You see the radio network, the transport, the core, then you have on top communications. But basically, you're going to be exposing APIs. You're going to be exposing capabilities into what we call the high-performing programmable network. This high-performing programmable network exposes capabilities that you can be consuming from the developer platforms and the API aggregators, and allows all the devices on the left of the picture really to access high performant slices of the network, high performant partitions of the network, tailor-made for the concrete use cases that they are actually delivering. And this is something that is actually creating a lot of interest into precisely the industry verticals because of the facility, because of the ease to actually create network-aware type of applications that are able to perform in a much better, in a much more coordinated way than with a traditional best effort type of network. So let me go into some of the key subcomponents that you will see whenever we are moving into this vision. And these are just a subset of all the subcomponents, all the sub-technologies that we are using when really thinking about what the vision would be. I have talked about, the sensing of the sentient network. I have talked about that you're going to be having a multitude of data sources that need to be correlated, that need to be gathered together. Then, of course, one of the key things that is happening when moving into 5GSA or moving into 6G is that we are starting to talk about what we call integrated sensing and communication. Roughly speaking, it's basically that you are using the radio waves to actually provide sensing, provide type of a soft radar functionality. So that would allow us, for example, allow the network to really map the local environment, understand the physical characteristics of the environment where it lives. It would allow to detect in a much better way moving objects by looking at the refraction of the radio waves. It really provides a better sensing from the propagation properties and detects, for example, interference in a much better way. So this is one of the key, not the only one, but one of the key technologies that we are using to provide that sentient type of behavior of the network of the future that we are creating. Now, will this substitute radars or lidars of these kind of things? No, not really. It will complement it. We are not at the level of accuracy that a radar system would give you, but we are getting quite close, and we are getting extremely, extremely good at really using this type of information to correlate and to actually infer how the network is performing and how the actual physical conditions, the weather conditions and these kind of things, that actually provide, hampers or performance gains or performance diminishes for the network itself. What else are we doing? I already talked about differentiated connectivity. This is the key aspect of what we are doing when moving into 5G and when moving further into the next generations that will be 6G and 7G. For example, we are moving from a pure mobile broadband bit pipe into really creating a platform connectivity where you are exposing APIs. You're actually enabling right now the natural language exposition via intents of what would be the characteristics that the network requires for a use case to actually perform the way it's supposed to be performing. Think about IoT, think about security, think about logistics, a fleet of trucks going into the roads and being able to actually provide all the sensor information that are coming from the trucks. Not perhaps the critical ones for the actual driving, because they will be on place in the truck itself, but still, you could be having a replication of those sensor information that you have in over there sent to the network as a way to really provide a digital twin of your logical fleet of trucks. The key aspect of this movement into differentiating networks is that it allows us to start thinking about new business models, models that enable, that actually encourage innovation, models that enable that equation between cost and revenue to start being balanced again, so that the telco networks continue, growing and continue creating and innovating, because that has been one of the major hampering factors that we have had in the last years for the development of 5G everywhere. The compute continuum. I have talked about this distributed type of execution environment. I have talked about how you're going to be having now an orchestrated way into which you understand that your workloads, not necessarily only artificial intelligence workloads, but also the 3GPP workloads. Think about, an ASF, an MSF, the traditional functions that you're putting into a 3GPP network could actually move into the network in an orchestrated manner, could actually take decisions by agents that actually understand that, well, because of the delay that I'm putting for this particular use case, it would be much better if I'm able to instantiate this particular user plane function closer to the end device, to the user equipment. So we are really creating a dynamic optimization of the connectivity based on the compute characteristics, as well with hardware accelerated type of capabilities, and based on AI agents that take those orchestration and those instantiation type of decisions, precisely by gathering all the information that I talked about from the digital twins and from the world models. Finally, what we call the AI native architecture. Yes, we have talked a lot about AI. Yes, it's coming. There's no way to stop it. Yes, it's already happening into the telco network. We have tried to start thinking about where it, gets applied in the first places. And of course, the very first use cases, the low-hanging fruits, have been in the OSS/BSS space. Everything that is related to the user interactions, to what happens with monetization, what happens with marketing campaigns, what happens when you use a natural language model to talk to your network, when you are defining intents and these kind of things. But there is a lot of ML that is happening today deep down into the network proper, into the hardware. It optimizes the way we actually provide the scheduling to the radio base stations. It optimizes the way we actually provide, for example, mobility type of decisions into the packet core. And it really goes much deeper into starting to communicate with each other. There are plenty of protocols that are happening today in the open source, really thinking about the AI agents are going to be talking to each other. NCP as a way to actually define the profiling, to actually define the context that you need in order for an AI agent to start operating, but also A2A, which is agent-to-agent type of communication coming from Google, which is an optimization, of a language model to actually allow AI agents to talk to each other and to coordinate how they're going to be providing information to each other. I talked a little bit about this. I just wanted to give you an example of the type of things that we are doing with large language models. We have, for example, a lot of information about language models that we are creating in our own internal IT operations. We are using what we call the Ericsson Language Intelligence, ELI, as a way to actually create a RAG type of telecom adaptive retriever and re-rank models in order to provide the best possible answer to questions about our portfolio. Our system integration type of units, they are using ELI heavily in order to understand much faster what they need to do, how to configure different aspects of the network. We are using as well it a lot for the drafting of technical documents. We are using it even for writing of code, simple code. Yes, it's actually quite good at writing simple tasks, especially for those ones that are repetitive in nature. For the really mission critical tasks, we do have senior developers that all the time need to be checking what the coders actually do. But yes, it's actually getting quite good at writing simple code that you are acting into your AI agents. Finally, talking about the APIs, yes, I already said it. I mean, the key characteristic of what the network of the future needs to offer is simplicity for developers. I mean, the network needs to move from being just a simple bit pipe to actually creating value, creating capabilities that developers want to use, creating capabilities that enhance how you're going to be creating the new wave of applications. Those capabilities could be as simple as really enabling differentiated connectivity, quality of service mechanisms that we have tried for quite some time. But it could be as well, understanding how you're going to be executing your AI workloads, where they should be executed, how you're going to be creating, automated marketing campaigns that are aligned with the type of offerings that you have into your network, with the type of restructuring that you have into your network infrastructure. It could very well be that we are creating APIs for developers to be able to request, for example, instantiation of user packet plane nodes close to the delivery, or that they could be, changing the way the mobility behaves because of particular optimizations that you would be doing into your application, these kind of things. And this is very much the effort that we are doing when creating this sentient network that actually tries to automate on itself. What are we trying to create then? We're creating a cyber-physical world. We're creating a network that becomes a digital representation of what you want to do yourself. I mean, it should be a digital representation of the communication needs of the physical world. Everything that we have enabled through the history into how we communicate with each other, we are trying to enable it right now in a digital way through distance into the type of sentient network that we are creating. It should be taking, inputs from the physical reality, simulating a digital reality that resembles as close as possible and as real-time as possible the physical reality, and enables all the application creators, all the application developers to really satisfy their needs, and especially innovate into the type of applications that we are creating as of today. This is the goal, and that's why I call it the sentient network. And again, that picture, I think that even if it's a little bit cheesy, but it's quite cool because of the vision of how all these different technologies together are moving, are converging into some kind of an architecture that actually becomes autonomous in nature, that becomes self-sentient, that it's able to understand its own state, and it's able to understand the requirements that are coming from the users, but also the requirements that are coming from the industry verticals and the requirements that are coming from the whole ecosystem that uses the network as of today. With that, I'm going to stop for today, and of course I'm going to be around, so feel free to come and ask me about all these aspects that we are talking about. There is so much more that I could be telling you, but I don't want to extend myself so much, but of course feel free to look for me later. Thank you for your attention.
Thank you. Thank you. And all of this is for a person to live more easily. What about the engineers? As you can see, we will have a lot of fun on network side in the future.
Absolutely. I mean, one of the key questions that I'm always getting is whether the arrival of AI will actually, provide operators with a huge excuse to fire people. And I'm always answering to all the CTOs around, well, you're not going to be firing people. You're going to be reskilling them. You're going to be actually learning them how to deal with the AI agents. You need to actually move your workforce into actually understanding this autonomy of the network. You need to move your workforce to understanding much more the needs of the AI agents, and then let the automation take care of the day-to-day operations of the network. So that's absolutely basic.
Okay.
We are going to need a lot of engineers.
Okay, we can continue discussion later. Thank you very much. While we in Serbia are impatiently now even longingly waiting for 5G, the world is going on. The new generations are developing very fast. Here is an opportunity to hear something about that. With us today is Dr. Dragan Samardžija, coming from Nokia, Head of Research Lab, Nokia Bell Labs, United States, who will present a very interesting topic, convergence of wireless and AI processing.
Okay. Dobar dan, TELFOR. Of course, I'm a, can you please put it? Okay, coming up. Dobar dan, TELFOR. Of course, I'm a native Serbian speaker, but since TELFOR has become a truly international conference, I'll switch to English. I'm representing here Nokia Bell Labs. Bell Labs, it's a research branch of Nokia. We're looking ahead 3, 5, 7 years. We're trying to help our core businesses, but as well to help a broader industry community. And in particular, we are very international, which I think is essential for our industry. We have departments, 2 departments in the United States, 2 departments in Europe, and the most recent one in India. And here my topic is convergence of wireless and AI, and I think it perfectly complements what we've heard from Ignacio. I'll be a little bit more concrete in terms of how we build stuff, and I'll be taking a particular problem of very radio access network. So let's bear with me, and hopefully I'll keep your attention before the break ahead of us. No more than 20 minutes. So, yes, you're deploying 5G, but we as the industry, we need to start working on what's ahead of us. And when we think of 6G, most probably the first serious deployments will not be happening sooner than 2030. So a lot of years ahead of you still to make good use of 5G. But we need to feed our innovation pipeline into 3GPP standardization, creating all of these critical patents and first proof of concepts prototypes. And this is what my lab is focusing on. Even though 5G is still a hot topic, I decided to give you a couple of concrete examples how AI is entering the world of radio access networks. Of course, as we develop 6G, we are very mindful of performance. We still want to deliver higher throughput, lower latency, improve battery life. But what's becoming dominant, as we've heard from Ignacio, automation, which is critical for OpEx, CapEx, making sure that most of the upgrades are, if possible, software-based. This is as well one of our key KPIs we would like to keep in mind when designing 6G. And of course, possibly create new ways of service providers making money. This is super important. We live what's known in a flat revenue world of CSPs over the last 10 years. Can we nudge it up? As a concrete example, I'll be talking about one of the aspects of the new 6G, continuation, evolution of 5G, and this would be AI, an introduction of artificial intelligence to the very bottom layer of the network, radio access. So, how we started introducing AI. This is the basic modem design. Modulator, demodulator. Could be the hardest one. A hard real-time functionality of the network. The old way, we follow a textbook. We perform channel coding, insert on the transmit side, pilots, we perform OFDM MIMO or a single antenna transmission. On the reception side, we perform the inverse channel estimation, MIMO detection, channel decoding, and whatnot. Even in 5G, Nokia started introducing the second row, piecemeal introduction of neural networks to replace conventional functionality with those improved upon ways of building physical layer functionality. Actually, Nokia introduced as part of 5G deep neural network estimator. But we as Bell Labs, we're pushing and exploring technology horizons further. And all of a sudden, we have replaced the full transmitter with a deep neural network, and we'll build a receiver as a deep neural AI network. For those of you familiar with AI architectures, those were based on convolutional neural networks, typically used in image processing. But we flipped it, and now we are using to improve wireless performance on the very fundamental radio access link. So what did we do? We built it proof of concept. We did use, naturally, GPUs. We have not used GPUs from NVIDIA up to this point because it did not make much sense. We built our first proof of concept using NVIDIA, but we could have used as well AMD GPUs. And out of Asia, 2 lead service providers, NTT Docomo in Japan, and SKT worked closely with us. They replicated it, and on the next slide, I'll show you some results. But the right-hand side of this slide shows how modulation, it actually does not look like a typical QAM QPSK that we got used to it over the years, but it's breathing, changing depending on the SNR of the radio channel. Just as one example, speaking about learning, adaptive nature of artificial intelligence introduced to the networks. Ignacio, this was your point, online continuous learning. So what did we do? With our partners in Japan, our system was replicated, and this is the most recent press release by pretty advanced service operator NTT Docomo. And they did in Japan have some true trials, test runs, and they showed that if you replace your conventionally built modem with a deep neural network, primarily receiver, you can easily improve your throughputs 30, 40%, and in some cases even 100%. And this was a surprise. We had to run experiments to really convince ourselves that this is doable. So AI on the radio layer really to improve the basic KPI, throughput, and with it as well could be a trade-off versus coverage. The second example, again, Nokia cannot work on its own. We need to work with our partners. In this case, it was not a customer. It was a terminal UE vendor, Qualcomm, the lead UE vendor with whom we operate closely or we work closely when it comes to 3GPP contributions. Qualcomm developed the terminal side. They're listening to the downlink transmission from a true Nokia G-Note B. It was a commercial product which we have modified. It's listening to the downlink transmission. It's performing what's known as downlink channel state information. And then Qualcomm has decided to use, independent of Nokia, neural network. They designed it themselves to compress that information. Most of you are familiar with the concepts of compression. Now we're using AI, neural networks, to compress and feed the channel back to Nokia Bell Labs base station. Our base station performed, of course, the inverse operation, decompression. We used our neural network independent of Qualcomm's, and we showed that the compression, it's roughly 30x 300%, and it was effectively used in downlink. Now, since the base station knows about the channel state information that the terminal is experiencing, was used to improve the downlink transmission and boost the downlink throughput and capacity. The key reason why we did it is to show the two companies independently developing neural networks as an embodiment of artificial intelligence can be fully interoperable while still keeping all the good stuff, the compression, 30x, and the downlink improvements. We did a true experiment. Again, this is the nature of our lab. From concepts to proof of concepts, measurements. This was in particular done in Murray Hill, New Jersey. Qualcomm brought the terminal. Bell Labs provided a base station on the top of the research building, a big parking lot, line of sight, non-line of sight conditions, consistently showing improved throughput gains in the downlink while independently compressing and decompressing. You can find it in a joint IEEE journal publication, I think coming up next month, between Qualcomm and Nokia Bell Labs. So I gave you two examples how truly neural networks are getting into the guts of radio access. The modem design, the first one with NTT Docomo, was based on convolutional neural networks. Again, you familiar with ResNet. The second one on Nokia's side was based on transformer neural network models. Again, for those of you that are becoming versed in neural network architectures. Let me switch gears. Super. But neural networks are using millions of parameters. Large language models, billions. Okay, immediately you would say, it's going to be hard to build those things. And I'm going to give you an example that even building it in a conventional way has been hard. As we delivered our 4G, what did we do? 20 megahertz, 4x4 transceivers. Then we went to 5G. We went up to 100 megahertz bandwidths. We added more transceivers, 64 transceivers in the base station side. I'm primarily talking about the base station side, even though a similar story is on the terminal side. And when we think about 6G, the first prototypes are using 400 megahertz of bandwidth and 500 to 1,000 active antenna elements, extreme massive MIMO. Super, this is how we are delivering higher capacity. This is how the end users see more data rates being delivered or CSPs having more users served in same cell. But actually, number crunching, it's extremely demanding. We add bandwidth, we add antennas. It takes a lot of compute, whether it's a textbook signal processing or even more so, million of coefficient worth of neural network. And the figure on the right, it's illustrative, but I think it's a reasonably, not a tight bound, but a looser bound on the chip size for performing L1 functionality, modem functionality, moving from the days of 3G, 2G, into the days of 5G and then 6G. Believe it or not, chip size actually grew significantly bigger now. The chip is significantly bigger now on the base station side than it used to be in 2000. And you may say, how come? We've been relying on all the good stuff behind what's known as Moore's Law. Miniaturization of TSMC, Samsung, Intel technology. Yes, we are riding that wave. But unfortunately, fortunately, because we're adding more and more antennas, bandwidth to keep end users happier, CSPs happier, the price we're paying is in a larger and larger silicon. And if you ask any of the CSPs, when they think about the radio unit and the silicon that goes behind the radio unit, they're saying, hold on, it cannot be more than 100 watts for your digital modem functionality. And for 6G, massive MIMO, we're currently calculating 5,000 tera operations per second. Keep it at 100 watts. It's extremely hard. Actually, Nokia Bell Labs, and not just us, we have a whole set of technologies that could be applied to build efficient silicon for basebands and UE processing. I will not go exhaustively through it, but I'll be showing you one example, a big change to how we perform compute. And it's called compute in memory. Within a chip, we are doing compute in a different way, catering both to neural networks and conventional way of massive MIMO processing. So what did we do? On the left-hand side, you would see a typical digital signal processing architecture. You have within your chip. Everything is within your chip. You have memory for your input data, could be inputs from your antennas on the receiver side, could be as well inputs from your camera if I'm doing any kind of a video processing. Then I have typically a memory which holds weights, beamforming weights, or could be neural network coefficients. Then I'm taking them to what's known as ALU, or here I'm calling it math unit, and doing it 1, 2 gigahertz, giga cycles per second. Billions, 2 billion cycles a second. Actually, this is a problem. We found out that the left-hand, and we're not the only one, we're hitting what's known as a memory wall. Shuffling data between the math unit, the intelligence, and where you store data, it hurts. And we came up with what's known as in-memory solution, where within SRAM, on-chip memory, you keep your coefficients, the gray boxes, the smaller gray boxes, and you feed data straight into it, and within SRAM, you're putting adders and multipliers. And this is resulting in 10 to 100x tera-ops per second per watt improvements. But I would like to emphasize here one point, the theme of this talk. This type of operation, it's essential when it comes to vector matrix operations, where massive MIMO, it's typical of, dealing with very large bandwidths, it's typical of. But guess what? Whoever digs into the guts of neural networks, most of them are dominated by vector matrix operations. So we are effectively coming up here with a converged physical platform capable of dealing with typical wireless massive MIMO processing and neural networks through the core operations, and these are vector matrix operations which need to be done very efficiently. We have built a test chip, 22 nanometer global foundries. And here for the local academic and technical community, I just would like to have you this in mind. These days, building chips became much easier, democratized than, let's say, 20 years ago. A small group, thanks to EDA tools, abilities to get access to foundries, global foundries, TSMC and whatnot, even small teams can build chips. And this is what we did. And we compared against the plain vanilla, how NVIDIA would be doing it versus compute in memory. And without getting into gory details, you're easily getting 10x, sometimes 100x tera-ops, tera operations per second per watt gains. We're building a whole SoC, which is furthering. This is from individual element, which is the processing element on the right-hand side, which consists of a small RISC-V. Again, for the startup academic community, it's a very friendly CPU. It's effectively open source CPU, which you do not need to pay for. We're building a bank of SIM, computing memory, that does very efficient vector matrix operations. And we're building thousands of them as part of SoC, creating a common compute in memory platform, both for 6G and AI inference. AI inference, like YOLO, those of you familiar, cats versus dogs, common platform. But that's what I have covered up to now, and I have just 2 more slides. It's primarily using our Nokia in-house proprietary built silicon. Yes, Ericsson is doing a similar thing. Serious vendors such as Huawei are doing the same thing. But Nokia took a bit of a divergence During the last year, actually Bell Labs pioneered it 2022. We have built 5G, and now 6G, a fully operational 5G on NVIDIA GPUs. 2022, achieving 10 gigabits per second. And to my friend from Ericsson, yeah, we built LDPC decoder on A100 Than NVIDIA. We have shown that, yeah, you can run your 5G. You do not need dedicated silicon. You can get something off the shelf, NVIDIA GPUs, Intel CPUs. And while you're running your 5G, concurrently, you can execute, again, this is a stock image of a YOLO. You can run your cats versus dogs, in this case, image classification using neural networks for non-RAN purposes. So this is another aspect. While we are specializing dedicated platforms, we're actively exploring, and now with partnership with NVIDIA, it's almost a task for our company to show that you can build your 5G and then 6G, not using dedicated but common off-the-shelf GPU, CPU silicon. And this is one, to bring it a little bit closer to our friends from the communication service side of the industry. For example, we've been proposing a hybrid, where on the left-hand side, you can build the top performing in terms of power, area efficiency, 5G with CUs, DUs using dedicated in-house built proprietary silicon, purpose-built silicon. While on the right-hand side, primarily in Germany, we have this as a use case in a factories where they deploy edge-of-the-network GPU resources for doing video analytics on the factory floor. We can use the very same GPUs to close the 5G and then the 6G link. So what I have covered up to now, and I'll be concluding, are two very concrete cases how we started introducing AI at the very bottom, the real-time part of neural networks, which tends to be the hardest in terms of power consumption and achieving real time, and no question about introducing intelligence to higher layers such as automation. And then I gave you our research part of Nokia Bell Labs on purpose-built dedicated silicon with 6G and AI convergence happens explicitly, and then more general use of available common off-the-shelf GPUs, again, riding the wave of AI-6 convergence. And the last slide, this is our new kind of a logo. This is what our new management insists on. We start being Nokia connecting just people. We started being, and I think our competitors equally so, connecting intelligence, but we call DIPS here, we took it first. So we are connecting intelligence. I was focusing on radio access, but of course other parts such as a fiber optical part of the network, it's super important for realizing the vision of truly connecting intelligence of whichever nature it is. Thank you.
Thank you very much and congratulations. I na kraju, došli smo do kraja. Ostalo mi je samo da vas pozovem da učestvujete u bogatom programu TELFOR-a. Ima tu puno interesantnih tema gdje možete da proširite svoje vidike, da probamo zajedno da pomeramo granice, da se družite između sebe, između ostalog TELFOR i zbog toga to je možda i najveća vrednost, da popijete kafu sa svojim kolegom, da razmenite iskustva i siguran sam da ćete na taj način saznati nešto novo i naći prilike da sarađujete i u budućnosti. I kao što to biva na kraju otvaranja ove ceremonije, ispred nas čeka koktel, da se malo podružimo i da počnemo sa uspešnim još jednim TELFOR-om. Hvala vam puno.